Hi, I'm Brandy Heflin. I'm a personalized physics instructor, and I help high school and college students feel confident and successful in learning physics. So I hope your summer breaks are going well. It's been a little bit since I've created a video for you, and I wanted to teach today about lunar eclipses because tonight, July 4th, 2020, going into July 5th, 2020, there will be a penumbral lunar eclipse. This eclipse will be visible in the Eastern time zone from a few minutes after 11 p.m. until a few minutes before 2 a.m. And the best time to view it, weather permitting, of course, is going to be about midway through that window, so around 12:30 a.m. So questions we're going to answer today include what causes a lunar eclipse? Why isn't there a lunar eclipse each month? And what is a penumbral eclipse? So what causes a lunar eclipse? As the moon orbits the Earth, it can pass through the shadow that the Earth casts where it blocks out the sun's light, as shown in the diagram here. So notice the alignment: sun, Earth, and then moon. And when the moon is on the opposite side of the Earth from the sun, we see it in its full phase. So a lunar eclipse can only happen when the moon is in its full phase. When the moon is in its new phase, it's in between the sun and the Earth, and we see it up during the day instead of being bright at night. So you might be wondering, why isn't there a lunar eclipse each month, given that the moon goes around the Earth once each month? And the short answer is that the moon's orbit is tilted relative to the plane of the Earth's orbit. So instead of going around horizontally like this, the moon is actually doing something more like this, where it's high sometimes compared to the plane of the Earth's orbit in space, and it dips below it at other times. So what the moon's orbital tilt means for eclipses is that most of the time, most months, the full moon does not actually pass through the Earth's shadow. As the diagram here shows, in fact, sometimes, sorry, I'm trying to get my pen tool going, sometimes the full moon is going to pass below the Earth's shadow, and in those months, the new moon will pass above. And again, solar eclipses happen when the moon is in its new phase. But then, depending on where the Earth is in its orbit, sometimes the reverse will happen, and the full moon will actually be above Earth's shadow, and the new moon will be below it. So as I was just saying, because of the moon's orbital tilt, we do have most times of the year shown in the shaded areas on this diagram where the full moon or the new moon is going to be, it's going to miss the Earth's shadow. That's these points here. But then in these lighter areas on this diagram, we have the places where the moon can line up with the Earth and the sun just so, such that either the Earth, well, the moon's shadow will pass over the Earth for a solar eclipse, or the moon will pass through the Earth's shadow for a lunar eclipse. So the lunar eclipse that's happening July 4th into July 5th, 2020 is called a penumbral eclipse. This is also called a partial eclipse. And in order to explain what that means and why we would call it this, we need to talk for just a minute about how shadows are formed. So I have a lamp up here, there's another here, and we'll do our best to use this lamp to produce a shadow on this piece of paper. So notice when my hand is close to the paper, I have a nice dark shadow, and it has a very crisp outline. And as I move my hand further away, notice what happens to the shadow. It's not just that it gets bigger. That's not the important part here. What matters is that the shadow gets fuzzier around the edges and it gets lighter in color. And that's because the light from the lamp is able to pass around my fingers and continue spreading out. And so we end up with these regions around the edge of the shadow that are no longer crisp, but instead do have some light hitting them, and that's where we get the fuzzy outline. So now let's apply this notion of shadow formation to the sun and the earth. So this diagram is not to scale at all. But what I'm showing here with the red and the orange lines is light from like the top of the sun that's illuminating the earth. And then right in here, that light is going to be blocked out. And likewise from the bottom, I'm using green and purple to show light from the bottom of the sun that will be blocked out by the earth. And right in here, that light will no longer be able to pass. And so we have this triangle region right back here behind the earth in my diagram. It's outlined by the red and the purple lines that I drew, where no light from the sun is going to pass. And that's going to be called the umbra. That's the darkest, trying to get a good color here. So this dark area is the umbra. That is the darkest part of the Earth's shadow. And then we also have here in between the green and the red, and then down here between the orange and the purple, this area is where there's going to be some partial illumination. So because the sunlight from elsewhere continues to spread out as it's passing by the Earth, we do end up with a partially illuminated region, and this is called the penumbra. I apologize, by the way, if you can hear fireworks going off in the background. I have to record in the evenings, and my neighbors are already setting them off. I've been trying to record around the fireworks, but it's not really predictable. So again, this is not to scale at all. The penumbra region is not really this big, and the umbra region is actually substantially bigger than what I've drawn. But the important thing here is that when the moon, give me just a minute to pick another good color. So when the moon passes through the umbra, we're going to get a total lunar eclipse. And when the moon passes through the penumbra, we're going to get a partial lunar eclipse like the one that's happening tonight. So outer space with the sun and the earth is not the only place that we can see an umbra and a penumbra, these regions where shadows are produced with different darknesses based on where light sources are being completely or impartially blocked. So this is a picture of a lamp I have in my home, and you can see right in here there's a dark region from the edge of the lampshade, and right in here is where the bulb itself is, which corresponds to the bright part of the shade. But then notice we've got this line right here, which kind of denotes where light is, not as much light is passing below that line because of the lampshade. And then also down here, we've got kind of another streak in the shadow where it's a little bit lighter there at the edge. So this is kind of like a penumbra type area. And this also down here would be a penumbra kind of area. And so I challenge you, now that you know something about how shadows are formed, next time you have a lamp on in your home in the evenings, take a look and see if you can identify some different darkness areas of the shadows. So tonight we're going to see a penumbral lunar eclipse as the moon passes through that less dark outer part of the Earth's shadow. I hope you enjoyed today's little astronomy lesson. I certainly enjoyed breaking set and teaching something a little different. If you'd like to connect with me to discuss my physics tutoring services, you can reach me at brandyheflinphysics@gmail.com. You can also visit my website, brandyheflin.com. And if you'd like to sign yourself up for my weekly newsletter that will start going out once school begins again in the fall, you can visit the link here. So brandyheflin.com/subscribe. I will send out links to the instructional videos I create each week, as well as specials on my tutoring services. You can also find me on Facebook at facebook.com/physicstutorbrandy. I love physics and I love helping you. Until next time.